Next thing I say may be mind-blowing to you. The tide doesn't actually come in and out. What? There is a bulge of water, two of them, on opposite sides of the Earth, caused by the sun and the moon, and Earth turns inside that bulge. When we say the water rises and falls tidally, what's happening is we are rotating into the bulge and then out of the bulge.
So the bulge is already there.
It's already there.
And all we kind of do is pass through the bulge.
Pass through, and the water gets high and it gets low. So we're stuck with language from our own perspective rather than language of what's actually happening.
We have one that's about here. These are all approximate locations. So they're spaced around. There's one down by Antarctica is down on the bottom. Let's see, we're gonna have one about here. There's one here. There's another one here. The Pacific Ocean has the most. It has about 5 of them there. We're gonna have one here and then one here. Okay, so we can see there are 12 amphidromic points. These are all their approximate locations in the oceans. The Pacific Ocean has 5 of them, and the reason is the Pacific Ocean is the largest of all the ocean basins, and because of its size, it's very complex. So the amphidromic points, there are more of them there. Now we're going to go through and we're going to shade areas. Again, if you remember, these amphidromic points are places where we have the lowest tidal range, so 0 tides. I'm going to now shade in places that have the highest tidal ranges. I'm going to do that with this purple pen. So we have some here, kind of between Africa and Madagascar. We have some up here. If we go west of Madagascar, that kind of stands out. We have bays up through here, behind the Aleutian Islands, up high in the Arctic, in these areas. And then again, keep in mind that these are actually pretty far away from our amphidromic points, so we would have lower tides, and the tides would get bigger as we move away from each of those amphidromic points. And that is my quick lesson on the dynamic theory of tide formation.